Hello. Is it okay? Audible? Audible? Okay. Yeah. So, okay. Let us continue the discussion. And now I'm going to discuss about battery management systems in EV and further developments in related to electric vehicle to grid and all. Now, one is if you want to talk about this, what are the silent features of traction battery for EVs, and ideally it should have some characteristics. So one is it should have a high energy density. Okay, it should be attained with one single charge. Okay, and at the same time it should provide a long range of mileage and high density that make possible to attain stable power, so that you will get a deep discharge characteristics for acceleration and deceleration of the power. And obviously we as a user we wanted high long life of the battery, so and then maintenance free, and then high safety precautions also we should take it. And also you should have a wide acceptance as a recyclable battery from the environmental point of view. So that way ideally your EV battery should have these characteristics. And this is now we are into this generation now. So lithium ion batteries, in further advanced lithium ion battery, lithium polymer batteries, and then lithium sulfur and lithium sodium batteries also going to be come up. So that is those things also will going to be shortly commercialized in the EV sector also. And why lithium ion is why popular nowadays? Actually, if you compare the specific energy versus specific power, so lithium ion is having the highest. Okay, anything is a power versus and specific power versus specific energy. So that's the reason actually now we are depending on the lithium ion actually. Now we can compare with conventional lead acid batteries, nickel metal batteries with lithium ion. So it has advantages with the more specific energy and density, and also energy for consumer price also less, and energy efficiency is more. Okay, 85% more, and self discharge rate. Even if you don't use it actually, so there is a self discharge mode will be there. So 5% only for the lithium ion battery, and obviously it will have more number of cycles for the durability. That's the reason actually now everyone is going for the lithium ion batteries now. And same thing you can compare with the current cost also, different batteries and all available, commercial available. So what is the next generation design of batteries what we expect? One is to further extend the battery service life to the 10 years. Normally people are talking about 2 years, 3 years, and not maximum for 5 years. So but we should see that battery life should be 10 years ideally. That is what future our ambition. And at the same time to cut the battery cost significantly. I already said it's going to be, right now 40 to 50% of the car vehicle. So we need to cut down the cost also. Now there are now, as you heard, that there are a lot of causes for the EV battery failures also. Okay, so some are that spontaneous combustion 38% reason, and then charge point equipment failure 5%, and then caught fire during the standard charging 14%, caught fire due to the short circuit, and battery backed socket 5%, human errors and all 6% like that and all. And now you will see some kind of accidents, many things, even in Andhra also, Vijayawada, and then Hyderabad, Secunderabad, many places. Every year this kind of accidents is happening actually. And government also very much serious about it, and they have given a lot of warnings in last year, particularly last before year. And 2021, this Ola and Economa and Pure EV also, they recalled more than 6,000 vehicles are recalled, and they tried to replace the battery also. So they rectified the problems and all with related to BMS and all. And there are some, particularly technically, there are some factors affecting the battery efficiency, not just only charging and discharging time and all. There are many other factors. Okay, look at this diagram. So frequency of the charge and discharge. So how frequently you are charging and discharging your battery, and then charge current rate, that is one, and at the same time charge time, charge voltage, self discharge, operating condition, discharge rates, everything is will directly affect with the battery efficiency and all. And at the same time during operation conditions there are many other factors, so like significant charging and discharging, high temperature, vibration. So all these things will matter to yield to failure of the battery also. And also similarly, so excessive battery charging, that is also will lead to the battery problem. There is another one. Okay, and similarly inadequate battery charging also will lead to battery failures also. These are all related to your material science and then chemical related things. Okay, we are not directly related from the electrical point of, but still I mean, we need to understand how this will lead to battery failures and all. And next is, this is also storage conditions where you are parking and then store your, I mean, batteries and all. This is also another one. So this picture will tell you, so what way you can make hybrid energy storage system for EV. So in this picture, hybrid is made with the help of, ultra capacitor. Okay. Now you can see the one topology like a passive parallel topology. So where you have a battery and ultra capacitor, you have inverter, and then you can drive the motor. So that's why you bring the hybrid. So this is a passive topology. Now you can see the active. So this active you can make, so battery and then DC to DC converter. Now here, so the same voltage is maintained across the battery and then ultra capacitor. But whereas here you don't need to maintain that. So now you can bring the DC-DC converter. Now you can bring the active topology here. And further you can make this with the diode. So where you can provide a unidirectional power flow also here. So that's one possibility here. And now next one is, this active topology. Now you can change the placement of the battery and ultra capacitor like this. Okay, this is one. And then you can make the parallel combination of battery and ultra capacitor, where last one is reconfiguration. So where whichever you wanted to use it, battery or ultra capacitor, you can use the switches like S1, S2, S3 like that. Okay. Similarly, one can propose this hybrid energy storage with fuel cell also. So fuel cell and battery. So now you can do the number of experiments, and thereby you can bring a lot of case studies on the for traction motor drives and all. So this way you can bring some research problems also here. And coming to what is battery management system. So now it's it's going to be like a battery monitoring system that record the key operational parameters like voltage, current, and internal temperature of the battery along with the ambient temperature while charging and discharge. Okay, this is what. So voltage, current, and temperature we are going to measure from the BMS actually. And now we can see how BMS will help and what are the objectives of the BMS. One is to protect the battery cells from abuse and damage. Okay, if you open the battery, okay, really if you open the EV battery, so you can see the cells only. Normal how you see the battery cells. So same like cells only will be there. Okay, so that will be connected in series parallel combination with reference to what is the voltage across you want it. At the same time, what is the power level you wanted to bring it. So that's it. And now second one is, so extend the battery life as long as possible, and ideally now in future generation we are expecting 10 years, and then make sure that your battery is always ready to use it. So now conventional vehicle also, so now immediately you start the ignition, exit, right? So we don't have any problem with conventional vehicle unless, sometimes if we don't use for long run, long time, then it's a problem again. But we should not experience that kind of abnormal things with the battery driven vehicles actually. Now what are the functions of the BMS? So one is, so BMS will take care charging controller, discharging controller, state of art determination, nothing but SOC, SOH determination, state of health, cell balancing. So each cell, so what is the charging it is. So now there are some software tools also available associated with the BMS. So how many cells are there in the BMS, and you can find out what is the cell level, say cell charging level also in the BMS also. And thermal management of the battery, so to protect from the environment, thermal temperature rise, and data acquisition system, communication, logbook you need to maintain it, and safety protection also as a part of this BMS function. And what way you can arrange your battery packs. So one is you can arrange the battery packs in distributed topology, modular topology, centralized topology. So distributed topology like this, you can find distributed like this. Now you can see this is a packs actually. Now each one has one printed circuit board will be there. This is one source. So where you have one master controller there. The disadvantage of this, this topology is, so you will have more number of circuit boards are required. But advantage is you have high reliability. Even this may not, it is not working, but remaining can work. So that way you can bring the more reliability in the distributed topology now. And next is modular one. You can make the modular one, modular two. Maybe you can increase the capacity of the battery also. Maybe you see first is this is a 20 kilowatt battery, and additionally you can add another 20 kilowatt. So like that you can add the modular way also. Battery packs also can be included here. And centralized topology, where all the battery cells can be connected to one centralized master controller actually. So this is another topology actually. So now this is the block diagram of the BMS now. So look at now, we need to sense battery voltage, current, and temperature. So these three things will sense it, and we will send it to data acquisition system. Nothing but you will have some kind of microcontroller there. So now, so that microcontroller will do the state estimation, that is state determination. Nothing but SOC will predict it, state of a charge. So that information outcome will be given to user. So user will take action manually. So what kind of action you need to take against to the battery condition and all. And at the same time, some actions can be taken automatically where this information will be go to electrical control. So now we can see the what is the battery temperature, ambient temperature of the battery and all. So now directly you can do some kind of thermal related actions. Maybe you can switch on the cooling fan. So directly now you can switch on the cooling fan, and that will provide cooling of the cooling to the battery pack actually. So that way maybe air cooling or some kind of coolant you can use that actually. So this is another way representing this block diagram. You have battery packs are there. So this is a charging point. Okay, charge you get it this through charger. So each battery pack has one slave circuit. Okay, 3, and you have one master controller. So now you sense the voltage current, and finally information will be given to user, and then cooling system to switch on the cooling fan and all. And these are the components we can divide in the BMS as a classified like a hardware requirement and software requirement. Hardware, so safety, security, sensor system, data acquisition, charge controller, nothing but DC, and then communication system and thermal management. These are all comes under hardware part. So software part, algorithm, SOC and SOH algorithms, cell balancing, fault detection, user interface. These are all user interface, nothing but some web app, some GUI, graphical user interface, something like. So that way you need to provide some software solution also. And this is how you can see the flow chart of BMS now. So initially you need to initialize your master controller, communication ports, timer, battery pack, and see that when do you want to measure the quantities, voltage current. That means you are not all the time measuring. So when do you want to perform the BMS functions and all, that time only you say yes, then you measure the voltage current and temperature. Then if you want from the temperature directly you take action control of the fan speed, or you can go to further action from the this one to determine the SOC and SOH actually. And nowadays people are using the machine learning applications now for BMS and all. So whatever conventional algorithm that we use it, so same thing you can use them for the SOC and SOH determination also. We can find one paper also in IEEE. So machine learning applied to electrified vehicle battery SOH and SOH state of art actually. It's published in 2020. Yeah. So what is SOC? Okay. So ideally the definition is like this. So the ratio of currently available capacity to the maximum capacity. Okay. So maximum currently available capacity to maximum capacity, that is SOC nothing but 1 minus integral IDT by, divided by Cn, where Cn is the maximum capacity that can hold it. So this maximum capacity will vary it. Due to aging number of cycles is over, so this Cn will vary. Okay, so that's what we need to mention. So that is what we will get in some kind of percentage. So based on this SOH, now we will try to find out what is the remaining amount of charging is available. So that based on that, how much distance I can travel it. Okay, so that's the advantage with the determination of the SOC actually. So what are the popular methods are they? Starting with the Coulomb counting, Kalman filter method, modified Kalman filter methods. So like that machine learning models. So like that some methods are available to determine the SOC nowadays actually. And coming to SOH, so SOH reflect the health condition of the battery and its ability to deliver the specific power compared to the fresh battery. So that means you need to, due to aging, number of cycles, so your maximum capacity will go down. Even now laptop you see, mobile phone it is, whenever you buy it, say it will come 3 days. So 1 day, last is it come to 0. Okay, similarly this battery also same. So that means to wanted to find out what is the health condition of the battery. So that means you need to compare with the specific power performance compared to fresh battery. Same company, same model, then you need to compare it to SOC, then you will find it actually. So that means you will get to know when I should replace my battery. You will get an alert. If you go on this mileage, if you go on this kind of travel every day this many kilometers, so after 30 days, this so and so day, you need to change your battery. So like that you will get some kind of alerts also possible from SOH determination. And similarly here also machine learning can be used here. So whatever feed forward neural network, recurrent neural network, so and then support vector, Bayesian network and all, these are all possible actually. And now this is a formula now. So SOH is equal to CT divided by C naught. CT is capacity estimate at the time T, and C naught is new battery nominal condition. You need to compare with the new battery actually. And now you can have another terminology like SOL. So now you will get some kind of remaining useful life in the battery. It's a continuation to SOH only. So you will convert into some time, useful time format. So you will get a time in terms of hours or days like this. You will define that what is the SOL of the battery and all. And now this is another concept, vehicle to grid. So beyond. Till now, I mean, what we understand is we take the supply from the grid to charge your battery. So this is a reverse, vehicle to grid. So when this situation will arrive, so why I should provide power from vehicle to grid? So what is the advantage? Why do you need it and all? So some case studies are there. So we'll discuss it. And you can go to this portal also, IEEE vehicle to grid technology portal and all. Yeah, this is the components required generally. One is this vehicle should have a GPS, and then it will be connected to anyway charger. That is a part of this EV smart charging infrastructure actually. So now anyway you will be, this charging station fellow will be connected to aggregator where you will get it a power from the grid operator and all. So that's how the same infrastructure will help you to get the, to do this vehicle to grid concept also. Okay. So there are some case studies from the real life V2G actually. So in 2011, so in Japan there is a nuclear disaster has happened. So in that time complete blackout has happened. So Nissan, there are some Nissan, there is a one model is there, Leaf. Nissan Leaf is EV model. So there are 66 Nissan EV vehicles is powered, provided the power until the grid was stabilized. That means, so you can use this car EV batteries also as your source of energy. So how you are using already home EPS systems also, same thing. So instead of going with home EPS system, you can use your vehicle for as a emergency source of supply even for homes also. Okay, that's what the concept here. And even now, United Kingdom also, there is one case study from Element Energy projects actually. So drivers are earning money also. Suppose if you don't have any ride, so overnight they take rest. So then they will sell the power to the grid. And next day, they will get the charging actually. So that they will get money also because of dynamic pricing. So that way they can earn money also. Okay. So now forms of smart charging. One is unidirectional control, that is from grid to vehicle. And second one is vehicle to grid, so back, reverse. And then this is a vehicle to H or B. So vehicle to home. Even your vehicle also can deliver the power to the home or building also. These are the future applications are coming up now actually. So we can try to avoid the home EPS. But only thing is, so whether your car will stay, how many hours will stay, whether car will stay, whether needy hours at home. That is the question again. Okay. And now this is the architecture of the smart charging management now. So this is one of the case study for many researchers now. So you have a multiple charging station in a city, 1, 2, 3 like this. This is another fourth one. This is the fourth one. So where these charging stations will have this EVSV, supply electric vehicle supply equipment. This is nothing but charger actually. And now, so to maintain this all charging station, we should have a smart charging management system is required. Some kind of a controllable action is required from the cloud-based thing. So this will link with the utility control center, this smart charging center. So where it will get a action from the power grid, where how do you, how much power you need to access from the grid and then deliver to the which charging station and all. So this is what smart charging management system we need to build it actually. So this will we will build from vehicle to this one through one protocol, that is OCPP. Okay, open charge protocol point. So this is what is open charge point protocol, that is now right now it is a 2.01. It's an open source now. So it's not proprietary. So there some researchers came forward and they developed it. So if you want to link with the electric vehicle with the charging station, this is the protocol, everybody should use it now actually. So this is what protocol actually. Even some BTech students also, they can do some mini projects on this, how to implement the OCPP protocol using Python and some codes also available nowadays actually. And this is a hybrid one. So where look at this power is you can take from grid. So this is AC charging, you can build it in the same place. You can build the DC fast charging also. So one place, one charging station, you can build both AC and DC. So that is what you can connect it to different batteries actually. So this is meant for fast charging, this is meant for slow charging like this and all. And of course, when you deal with directly, this smart charging infrastructure, so there is cyber also included. So there is attackers also there, and where they can steal information, and even there are some kind of anomaly they can impose it, and then that will lead to some malpractice also, some building other informations also, or they can steal the user information also. Related to this, there are some kind of faculty from particularly computer science also. They are also working towards the cyber security issues for EV charging. So many engineering colleges, CSC faculty also, they can take this kind of problem statement for the research also. We have some good reports also. So electric vehicle charging cyber security report from USA and all. So good reports are available. This intrapolarity public EV charging infrastructure report. And some major companies, they also join their hands like this. So Honda Motor and then General Motor, they jointly together, they come up with one project, blockchain research project on EV vehicles, grid, smart grid interoperability. So that how the smart grids will help to, charge, scheduling the EV and then stabilize the grid and all. So this is the combined project actually, major project. And this one company, they focus on VETIA and vehicle to grid and everything in India. This one company from USA and even ABB also. So vehicle to grid. So like this. And this one Fretima Energy is there. So vehicle to X, nothing but vehicle to anything you can connect. Wherever you wanted to energy is required. So now your vehicle can act as a source of energy. So directly feed your power to the that emergency loads or prioritized loads. So vehicle to X, anything, vehicle to anything like that. So many now, job opportunities are there for students and young engineers now. So India is expecting by 2030, 2030, there are 65 million jobs are required in automobile sector, and even MSME also they give a lot of training programs for the EV charging station infrastructure and also. So regularly we see some kind of these calls in newspapers also. And some interesting literature also available. Now look at this is one of the interesting to me. So where in this paper the authors are quoted 2000 plus papers on various topics which are connected directly to the electric vehicle. Okay. So power quality, scenario study, electric market, demand response, like this V2G, battery management. So like this, they made a chronological literature survey of the electric vehicle interaction with power distribution, from which you can find a lot of research paper, problem statements and that. This is one good case study here. So you can see that there are three sources are available. One is grid, solar, and battery. So where these two, AC to DC is bidirectional, because we can pump the power to the grid also. This is a battery bidirectional. Now this is unidirectional. Anyway, solar will not receive power back actually. Now you have these are 5 charge controllers are there. So you have 5 vehicles arrived to get the charging from this this hybrid energy system actually. Okay. So now what is the case study now? So you can see what is the power flow management for this existing idea. So like look at you need to determine what is the EV's power is required, what is the power is available with the PV, what is the power available with the battery, and then now you can calculate that whether the PV's power is more or what is the power is available more with EV or battery. So now you can take that step. If it is yes, now you can go with EV scheduling using the PV. If not available with the power with the solar, then you can go with the grid, and then you can schedule the PV scheduling also. So that next vehicle they will get charging from the solar actually. So this is how you can make the case study also. This same one. So now in this you can elaborate this research statement. So let us make that chargings available in the fast mode, slow mode, and average mode. So like this, okay. So now you can make the constraints, okay, for a different conditions actually. And now you can look into this flow chart actually. So new vehicle arrived. Now you will make a question to the vehicle. So whether you want fast mode, whether you want slow mode or average mode. So like that. So now he wanted so fast mode. Then he will take the fast mode. Then he can switch over to average mode also later stage. So after a few hours, after 50%, like that you can make algorithm also. Finally you will take the departure. And if not available, you can go with the waiting. You can tell the waiting. And if you want to switch over from the average mode or slow charger to fast mode, then based on the priority, you can announce the waiting also. Okay. So this way one can make it. And now I added some content regarding this IoT also, because this workshop FDP finding some what are the solutions, IoT solutions for the electric vehicle. So generally IoT is it's not new, but actually it's interestingly you see many IoT devices are emerging nowadays actually. You can say by 2020 itself, so world population itself 7.6, whereas you have internet connected devices per person is 7. Okay, like you have a smartwatch, mobile phone, laptop, desktop, like that if you count it. So each person, there are 7 devices per person is having, and almost 50 billion internet connected devices are available in the world by 2020. And this out IoT is evolved. So initially there was 2 computers were connected, and then we made it a host to host connection network, and then we made it internet, and then mobiles also included. Now people are also there, PCs and all. Now everything now, any physical device now it be connected to internet now. So that way it is now Internet of Things are now emerging now. Now, what are the elements in IoT generally? So, first point is you need to see that what is the quantity. You need to sense it. Whether you wanted to sense voltage, current, or torque. So, what do you wanted to sense it? Okay, that you need to identify the tag, and for which suitably you will select your sensor. Okay, whether you are sensing current sensor, voltage sensor like that. Suitably you will deploy the sensor. Then whatever the sensor, sense the quantity, then you will transmit that quantity to the your computational place. Okay, that is maybe in cloud. Okay, then you will choose a suitable communication platform, whether you want to depend on Bluetooth or Wi-Fi, whether it is LAN, so that what is Zigbee, like that and that. Then finally you will use the data into some computational place where you will perform the task based on your application. Finally you declare your results. So like that IoT will perform it. So this is one of the high level data flow is it, where you have wearable electronics and then sensors are there. So now you can send the information to your communication processing devices will be there. So finally you will take that one to cloud. So where you will perform the real time processing there. And at the same time the output will be in the form of some kind of visualization, representation, recommendation. Maybe with the help of data analytics where people will project your output actually. So you can make the data archive also for future references, some historical data or something like that. And primarily these are the applications of IoT in electrical. One is IoT SCADA, okay, in the future that is going to become up. So connected public lighting. So whenever now highways also, people will come with some, students also come with, whenever motion is there, that time only we can have some kind of lighting and smart metering, anyway smart meters. Government is also insisting to deploy the smart meters actually, that's one. And building automation, smart inverters, smart grid applications actually. And this is what SCADA system. So first generation system is with connected to wide area network, that is a WAN. And the second generation is a LAN, and third generation is a WAN. Okay, this is a cloud based. Okay, and but still it is not the completely remote control. Is the fourth generation SCADA is completely cloud based actually. So this is what IoT based cloud based SCADA system may emerge in the future actually. So right now we are into third generation actually, and of course some places LAN also it is available. And this is one example IoT aided transmission tower production, and you can see some kind of sensors. You can see camera, sync node, and leaning sensor, vibration sensor, anti-theft bolt, and like that many sensors are placed into this cover. Now you can see that we don't need to, when some the work is here, some kind of excavation work is going on around here, transmission towers here. So for which you wanted to see what is the production, what happening in the transmission tower. We don't need to sit at this place. You can sit it remotely and you can monitor what is work going on here actually. So this way IoT can help you. And we need to see what kind of layers you use it. One is simple 3 layers actually. One is prescription layer where you depend on what is the kind of sensor that you use it. What you based on the parameter you sense it actually. And next is you need to select a suitable network. So to reach your computational place. Okay, there's a network you need to select it. And finally you need to see that what is the application layer. So what way you wanted to bring your outcome based on your outcome and all. And now we can classify the IoT problems also now based on the network. One is wide area network. So wide area network you will see in the electrical engineering, power generation, transmission side. So now you will find the different problem statements here. And is neighborhood network, that is so power distribution side. So home area network. So you will see the utilization level. So the power consumption here, automatic metering, smart meter, smart home, power load condition, energy consumption data collection of the smart homes. Okay, and then EV charging and discharging. These are all problem statements under HAN. So home area network actually for IoT. And now you can link like this. Okay, even building home control panel that will be again synchronized with the building also. So sometimes you see some kind of advertisements in TV also. Is it right? For home appliances, he will forget switch on his AC geyser and all, but he will go to office. From there he will switch on his geyser or something. Is it right? Same way this IoT framework will work it. So it behind it actually. It can be extended for the large power generation also. Like you can include the different number of power generation, like including conventional solar, thermal power plant, nuclear, and non-conventional like renewable energy like this. And then you can connect it to directly your homes. So, but totally it will be controlled through web-based smart grid architecture network actually. So it's a cloud-based actually. So this is also possible. And this I think repeated slide from the morning lecture. And if you want to focus on big data based, so one can do the planning analytics, particularly this renewable energy capacity forecasting. So what is the forecasting? For solar generation in this particular for next 5 years or something, and then DR penetration, distribution energy resources, and electric vehicle penetration also. So how many electric vehicles will going to be come up in this area? How charging is going to be scheduled? So those things are now related planning analytics also. You can do this thing also. And blockchain technology also coming up actually in this actually. So one area is where you can find out in operations, where you can do the store all the information about a renewable energy certification. So even now government, if you want to take up some kind of task and something work, so whether we'll see that vendor is registered with government of India, whether it's certified agency or not. So all these things using the blockchain, you can try to find out them. So because this this application is very traceable and then transparent also. And you can see some application with the direct retailer and prosumer. Prosumer is nothing but he will be consumer as well as deliver. So now I have a solar plant now. So now through solar plant I will generate the power, I will sell it the power to the grid. So my conventional is I am a consumer, but I will become a prosumer also by delivering power back to the grid also. So EV management and P2P, P2P transactive energy, energy trading, demand response. These are all different problem statement we can solve using the blockchain technology now. This is the overall idea. So P2P energy trading in the smart grid in future actually. So now you see that there is some community. So community, there are users are there, and then electric vehicles are there, grid is there, charging stations, everything is there. This is how you can design your own community, and this is another community here. So you have a battery aggregator is there, okay, and this is the prosumer where he consumes and then deliver it also, and here also another person is there. Now you have substation now. So you see that how the grid trading will be happening between the different one actually. So every user is connected to directly charging. So this is a distributed one. Okay, you can take the power from anyone. So that's such a way that this architecture is designed. So finally you will get the energy trading also. Okay, and this is slide again repeating. And in future, we see that some developments in smart grid. So further it is going to be cyber physical system in energy. So that means, so every physical element will be connected to cyber. So particularly in electrical engineering, so whatever you see, there are many major equipment, generators, motors, transformers, relays, circuit breakers, everything is physical quantities only. So those physical quantities directly labeled within a cyber. So that is one application. Now further you can see that human. So because ultimately whatever this every equipment, whatever operation control will be done by the human only. So human interface also can be bring this this scenario, then it will become a cyber physical social system in energy. So that means human participation also will be taken consideration actually. So that's how this energy system evaluation will happen in the future. And finally 4 technologies will be future linked. So one is energy, energy technology where we focus on power generation, and at the same time we need to know how you are trying to operate and control. And anyway, whatever this energy is now generated, that we will link with loads. Okay, but at the same time we need to focus on this new area, that's IT or information. So how do you synergize these 4 technologies and all? Okay, and I listed out some of the problem statement here for the what are the future direction, challenges, opportunity EV. One is specially designed electric motors. This is one of the area where we neglected. Every time we try to import the electric motors from the China and other countries actually. So this is one area untouched actually. So now we can focus on how to design a specially designed vehicles traction. So already morning I discussed it. What are the ideal characteristics your traction motor should have it. So accordingly you can design your motor. That's one. And next is multi-level inverters, where you can propose with the different topologies. Okay, people will propose with multi-level, same 7 level or 9 level, 13 level, whatever. But I will propose with a different circuit. Okay, but same application, same level. Okay, and next is people will propose a different control algorithm. He proposed one controller, I propose one other controller, and all. So like that, this is one area. And there's parallel inverters and redundant inverters, because in EV we need to have high reliability. So even if you use only one inverter fed with motor, if the inverter fails, then your car also will stop in between. Then if you have parallel inverter, at least so other inverter will take it. Even if you want higher power, so both inverter can power the more than rated. So double the rated power and rated power you can deliver it. And redundant inverters also, why even one fails, other one will act it properly like this. And hybrid source and energy management. So morning also I said, so one is battery, ultra capacitor, battery and fuel cell, or battery with petrol, battery with diesel, battery with gas. So like that you can bring the different hybrid source and then you can work on the energy management. Okay. Even last year also one of our BTech, my batch has done it. I given case study. So you have a hybrid vehicle like battery is there and then conventional fuel is there. Conventional fuel is petrol is there. So then, so the task is based on the different driving cycles, maybe city, rural, highway, like that. He has got the different data sets. Okay, so for the according to data set, what is the best optimized usage of the fuel? Okay, if you want to travel on highway, you want whether you wanted to consume the power from the fuel or battery, which is economical. So you need to find out. So that way you can do the energy management strategies also. And next is the next generation batteries, but it's not directly involved with the electrical, but chemical and then material science, nanotechnologies. They have a lot of scope and to work on this next generation batteries. And next is battery management systems. Anyway, we discussed just now. We have a lot of scope. And in this battery management, we can bring a lot of features. How do you connect with directly, more, attractive with, users and then owners. So that is one. And next is EV charging infrastructure in the static, dynamic, wireless. So there are different types are there. This is one possibility is there. And renewable energy based charging station. Maybe you can see the one charging station place, 1 acre place. Maybe in the same place now you have a solar is there, wind is there, you have a grid is there, battery is there. Then you have electric vehicles are there. Then how do you do the optimization between this source to load? Okay, now that way you can do the case study. And next is vehicle to grid and vehicle to anything. So you can design it actually. So you can make a dynamic, dynamic pricing and how many vehicles you wanted to send power to the grid, and then vehicle to X also. So that way you can make one problem statement. And then integration with the DC, distribution generation or microgrids, including optimization. So just now I said, okay, with reference to renewable energy based actually, similar to that. And demand response and transactive energy management. So where you will include the economics also. Okay, suppose you are dealing with solar, so you need to include a solar cost also, wind cost. Similarly, electric vehicle, now what is the charging, how much amount you pay it. So all the economics, not only technical information, you need to include the economics part also. Then you will work on demand response and transactive energy. That's another area. And smart charging management system. That's already I told you also. And final one is cyber physical system based solution. Okay. Now whatever now battery or BMS or vehicle or user. So anything now you can make related to the cyber physical system, solutions and that. So this is how you can find out a lot of problem statement. And similarly, you can see the popular trends in the power electronics, because without power electronics, we cannot build EV. So in power electronic based also power quality. So that's the first asset where people will work at it. So in power quality, we can achieve that power quality with and without additional devices. Both are possible. Okay. So where we have sometimes a minimum equipment like active filter, StatCom, multi-level, multi-pulse, multi-stage, isolation transformer, solid state transformer, like that you can use them and then bring the power quality as per the standard. And second one is complexity reduction, where you can reduce the number of switches in our converter. So maybe 6 switches to 4 switches, and number of the capacitors, number of the storage elements also you can reduce them also, so that you can minimize the loss and all. And next is you can improve the efficiency. Always you have a scope, you have a 100%. Nobody cannot reach 100%. Is it right? So till you reach 100%, you have a scope and reduce the loss and bring the high reliability and stability also in the power electronic. Multi-port converters. This is also another research where you have multiple source. Okay, even you have input side also, you can have multiple inputs will be there, and at the same time you have multiple output. Even sometimes you see the power supply. Sometimes power supplies can give 3 outputs, 5 volts, 3.3 and 12 volts. So that way you have multi-port output. Similarly, you can see input side and output side also based on the application. Okay, so stage by stage you can bring the output. And then hybrid and parallel operation that you can do. Suppose you have solar and wind, so you can make the hybrid operation like that. And then operation and dynamic condition analysis. Okay, so people who go with mostly steady state operation, but you can examine this your power electronic converter under dynamic conditions. You propose it with the different dynamic conditions and analyze it. And next is emerging semiconductor devices like silicon carbide and gallium nitride. So now people are now till now is worked with IGBT and MOSFET only. Now you can go with all the performance. You can repeat with new devices like silicon carbide and gallium nitride and all. And then now you can propose novel algorithms for electronic. Always we have a scope. Hybrid algorithms. You can propose a conventional with new algorithm like machine learning and all. So 2-stage, 3-stage algorithms also possible now. And finally, this is another one interesting. So IoT, ML and cyber-based power electronic control. How your conventional power electronics MOSFET IGBT will be connected with IoT. So that communication interface also you can work on it. So these are all different research problems actually. And further future, beyond electric vehicle battery driven, so hydrogen vehicles. One day maybe hydrogen vehicle may dominate electric vehicle also. And then solar vehicles, all electric aircraft, autonomous cars, okay. And even there are some companies also, Tesla, BMW, they also experimented successfully autonomous cars and virtual cars and then flying cars. There are 2 companies, Fertiga and then one more company is there. So they already successfully trialed it. They commercialize the flying cars also. In future, there are some flying cars also we may see. And this is one of the virtual share car sharing. This is one video from IEEE Spectrum. And if I click, and their video will project it here. So this is nothing but petroling application where you see some kind of a 5G interface device will be there. So everything streaming will be there. It's autonomous. No driver will be there. Okay. Still he will do the patrolling and then give the information to the control center actually. So that video is there here. These are the flying cars. There are 2 companies, Aeromobile and then Fertiga, Terrafiga. These are 2 companies. They commercialized already flying cars. So they can book it. Okay, they can book the cars, flying cars also. Now, what are the types of open source actually? And to implement any work, actually, it's always difficult to depend on some kind of proprietary or some kind of a commercialized products and tools. But nowadays, actually, there are alternative tools are available from open source. These open source tools can be maybe software, coding, and server and cloud computing hardware also. Okay, maybe some kind of hardware where we can mention open source. So, for example, Arduino and Raspberry Pi. Okay, even if you buy Arduino Raspberry, you can try to change it. Okay, circuit, and you can manipulate the circuit, and still you can do because it's open source. So there is no problem. Okay, these open source now free to use, free to share, free to change, even free to sell your work also. You can earn money also. So that's how many industries also now focusing on open source tools to reduce their investments and all. And I'm coming to last end of my presentation. I'm bringing some general content here related to project execution. Right? So how to execute project, academic project, research project successfully. So first is you need to choose what is the research area of work you wanted to work it. Okay, maybe broad area, some solar energy is very broad. So like that. And then in that, what is the problem to be addressed? Very specific problem, maybe efficiency of the solar cell. Okay, solar cell efficiency is only less than 20%. My aim is to increase solar cell efficiency to 25%. That may be problem. Objective is that one. Increment of the solar cell efficiency to 25%. So in these objectives, you may make some 2-3 bullet points, 1, 2, 3, like that. That too you arrange a sequence. So I will execute first one, second one, third one. Like that you make the objectives. And then you go with the literature survey. From the literature survey, then you do the state of art. So till date, on this problem statement and objectives, what people have done it before me. Okay. So from then, now you can find out what is the scope of work. Sometimes after the state of art, you need to revise your objective and problem statement. You will find that somebody has already previously done it. We don't know till you search a literature survey. Then you have to revise your problem statement and objectives also. That is also needed. Then you have some constraints definitely, maybe laboratory equipment, college facilities, time, guidance, many factors will be there. So based on all the constraints, now you have to stick to what is the scope of work possible for you. So you should not, exaggerate, tell that, I will do this much experimentation, this much patents, or no. And finally, you can propose your project plan, and then finally you can make an action plan, roadmap, targets based on the timeline. So first month target, second month target, like that. If you have whatever BTech project, MTech or PhD like this, and you can have a review timely. Department will conduct it, so semester wise and all. And finally you can submit it. So this is how any project, not only BTech project, MTech, PhD. So everybody, most of all the faculty, institutes, they take care this kind of a flow of it actually. Okay, so this one. So definitely this project will decide the job potential for job seeking and career path. So because every CV we highlight academic project, whenever we go to interview, they will ask what is your MTech project. Even faculty interviews also, if you go, even you did a masters 10 years ago, they talk about what is your MTech project. So that is very common. And now what are the trends? What way you execute your project? Okay. So one can do only modeling. Modeling is nothing but in engineering, we will model our system using mathematical equation. Sometimes you see the papers also IEEE transaction. Simply it's only equations. With equations only they publish transaction papers. No results also. So that is also fundamental starting where you can go with a complete modeling. That's one trend. And next is design aspects. You take one system, how do you design it? Maybe solar system is there. How do you size your solar panel? What is the converter sizing, loads, everything. So that way you make the design and sizing. And then development. That development in the simulation or hardware. Okay. So that way you do simulation. Next is you can do the analytical and critical studies. Okay. So I will impose some kind of some case studies. Then I will do the analysis. Then I will impose some kind of critical analysis, critical studies. I will do the abnormal conditions. Okay, safety related. So like that you will bring. Then you compare the things also. And the control techniques. I use one control technique in the literature. He proposed other control. Then you can compare the different control techniques that is possible. And optimization. Engineering, everything should end with optimization. Whether it is algorithm, whether it is a physical element. So we need to see, we should be very simple and then compact and sizing also, everything. Okay. So what kind of optimization you are trying to bring it to your solution. So that is optimization techniques always is going to be end of your engineering process. That's one. And next is comparative studies. Method A, method B. Okay, like that you can compare it. So you can make the comparative studies always. Integration, maybe solar and wind integration, or you can integrate the different components also. That way you can complete your engineering solution and all. And next is experimental studies you can do directly. Okay. And finally another one is performance validation. Suppose some system is ready made. Okay, you have a solar system in this campus now. So now the students can take directly performance validation of the solar plant existing at this college. So it's a ready-made system is available. Directly go and perform the task. So that way you can do the performance validation also. Okay. So this way, sometimes you can combine them: design and simulation, simulation and experimental studies, and simulation and control techniques, simulation optimization. Like that, you can combine the trends also. So that way, one can do the good project work or research work also. Okay. And what are the areas is emerging now? Focus area. One is renewable energy is hot topic, solar and wind. Okay. And then power electronic converters, it's evergreen. Okay. So whatever now you go in the further decades also, it's going to be evergreen. Without power electronics, we cannot manage or control our electricity. And next is electric drives. Industry is highly reliable on the electric drives. That's one area. And electric vehicles now is emerging. And then smart grids, a lot of scope is there. And microgrids, where we can combine the different distributed energy resources, and then you can form the microgrid. And DC grids. So now there is some kind of stories also, AC versus DC. So now maybe in future also you may see in the house also, along with the AC you will find DC also. So like maybe battery for a vehicle also, something like. So only DC, there is a problem is every DC appliances will have some different voltage. My mobile phone is required 1 voltage, laptop is required 1 voltage. So monitor, keyboard, so everything is required different voltages. That's the problem. But how do you make the uniform and then make the less DC power supplies for the same application? And next is energy storage technologies. Okay, hybrid in that also you can find. And next is EV charging infrastructure. This is one problem statement: AC, DC, fast charging and all. So energy conservation and management. Maybe this is with related to mechanical engineering also, even within the electrical engineering also, that is also possible. Or chemical, maybe fuel cells, like that. So energy conversion management is evergreen again. So that is also for us. And modern power system, load forecasting, fault rate, this also. And of course, latest technologies like IoT, machine learning, AI, blockchain, big data, cloud computing, deep learning in the power and energy system. These are now, morning also said, we are going to see that this part, in the electrical engineering 2.0. So this will bring you that actually. Okay. And what should be aim of project students? Okay. So the first one is ideally faculty we said publish your work in journal. That give you a lot of reputation, that give you a lot of weightage points and all. So next work, I mean at least conference. If not, then so it should motivate you for higher studies, because when you go to higher studies, they talk about BTech project. Even if you are secure the gate rank top 10, and there is no guarantee you will get a MTech seat in your dream IIT, because there is interview will be there, and if you fail it, so you don't get it there actually. Even I have seen some example from my own students also. He wanted to join IIT Bombay, but he failed in interview. He has a score of less than 50 gate rank actually. So his BTech project was weak actually. So like that. And next is to solve the societal problem, or you should have some aim to solve industry problem, and to get an innovative award from Government of India, Industry and Institute, because the government also will give best thesis award also. Even BTech, INA, National Academy of Engineering, BTech, MTech and PhD level, they give best thesis award actually. So they can get it, and you see that your project is deployed in the field, or you want to become an entrepreneur, at least that should motivate you. Or finally, you can make you launch your own startup company from your project. So these are all possible aims. At least students, they should have at least one aim. Otherwise, what will happen is it will become some kind of a book that will keep in racks. No use. Nobody use that no record actually. Thesis. And finally, this is the best thesis award you can get it. That is also possible. Or at least worst case, your project should help you to get the attractive placements at least. So that way it should help you also. Okay. And tips for research. And one problem is everywhere, we don't have access to the download the literature and all. So now if you want to start any research for a young faculty, so you don't have to worry. Now open access journals also there now. So even now with the same topic, you can find some kind of, nearly 50,000 to 1 lakh materials available now. So that material is enough to start your research. That's enough. And next is read the paper carefully, understand the technical language of the content. Sometimes we struggle at how to write a paper, even if you do the good work, MATLAB simulation or any hardware, but we should know how to write a paper, for which first we please read your paper completely. Whatever now you download the reference paper, how they have written the how they have written the introduction, how exactly they explain the results, they obtain the results, how exactly they explain the results, all the fundamental things you need to understand that. And then you need to choose your guide, of course mentor for collaboration publication, and select a research area with minimum and no experimentation. Okay, in electrical engineering also without experimental you can get the IEEE transaction, particularly it's power system background. So they do that. They don't do any experimental. 99% engineers, they directly go with programming, MATLAB based programming, Python based. Still they get IEEE transaction. So that's why if you are beginner, so let us go with minimum or no experimental. That way it is make easy to you. And next is you can execute the work with the open source tools. There are alternatives are there every software that you can use them. And publish in only Scopus or web of based journals. This is what government and colleges only recognize. If we are publishing other journals, they are not caring about it actually. And my suggestion is personal one. So publish with IEEE conferences. And conferences are many places are happening, many agencies are conducting. But actually what is advantage with IEEE? So your IEEE conference paper will be uploaded in the same way journal papers also uploaded. That is IEEE Digital Explorer. Okay, digital library. So that means where you will get a citations easily. But whereas if you publish with other platforms, nobody will search for your paper, your conference paper. Okay, if many other platforms are there, so if nobody will search your paper in other platform, but people will search in IEEE for good papers. Automatically, when you're searching it, along with the journals, your conference paper also will list. People will get citation, will do citation for your conference paper also. You will leave your H index, and then your citation will improve with IEEE conference. Okay. And constraints, of course, during execution of project, one is place of work environment definitely will be there. And next is institute lab facilities, timelines, and guidance also. But actually nowadays, knowledge is open source, is unlimited. So you have to use that main motto. And then many places, if you don't have facilities, nearby institutes are there, particularly government institute like NIT and all. So governments are open for anyone, any public. So any faculty, if they want to come and research, and they will share the facility. Even with the central government also, any equipment we purchase it, we will enter into one portal is there, iStep. So in that actually, if you purchase this equipment, how much time you spare for outside people? We need to enter that. So 30% in the year, 10% of the year and all. So people come and use it. So that's how you need to use the facilities also, where our government needs to have best facilities and all. And then any project, it should be simple, economical, user-friendly, robust, reliable. Then people will say excellent. And of course, After work, so you will need to improve the technical writing skills. One is project proposal. Okay, maybe if you want to getting funding, okay, and even particular funding only this one. And next is project thesis report, and then conference paper, journal paper. So these are the where we will, need this technical skills improvement and all. And to become extraordinary, definitely you need to have out of box thinking for problem solving. Otherwise, you will become ordinary. Nobody will pick, and your career will be not elevated that much as expected actually. So we need to come forward and then show you exhibit that. And three important learnings are required actually. One is continuous learning, whether it's teacher or student. So without continuous learning, otherwise you will become outdated. So nobody will be recognized. No, it's getting over. Yeah, yes. Yeah. So continuous learning, and next is self-learning. So once you complete your graduation studies at the college, and nobody will be there to teach you. Okay, everything is 100%. 100% is going to be self-study for us. Okay, even the students who are going to be join the jobs, so they are into completely depends on self-study only, and global learning. So everything is global learning. Whatever technology we work on in this India, same technology. I think America, everywhere is the same technology, same fundamentals, same basics only. So these are the three continuous learnings are required. Three learning practice, and this is about NIT Andhra Pradesh this one lab. So this is funded by DSIR actually, Common Research Technological Development Hub. Okay. Now this lab is established 2 years ago. It's till now we have equipped with 2 crores equipment is available now. We have a website is there. You can search in Google also. And mainly we see that the outcome should be mapped with MSME requirements. Okay. So MSME industries are there wherever who are working in electronics and renewable energy. We try to see that our output is mapping with them and all. So this is how we do, and we focus on renewable energy, including EVs actually. So this is what we function it. Core functions of this center is system modeling and design and sizing, programming algorithm, simulation studies, analysis control, forecasting management, development planning, rapid prototype. So that's how we will help the MSME companies who are the renewable energy sector actually. Okay, and we work on these interface technologies also for this technology. This is one of these startup from our department where I am the founder actually, one of the founder in Deep Connect, and we can go to this website and find the more details about it. We work on these EV chargers and now smart grid technologies, renewable energy. These are the primary areas where we work on it. This is one of the example where, so you can see how industries work it. How it is different from the academic perspective. This is one of the case study I wanted to bring it here. Suppose you see the power supplies in industry, you will see the different power supplies actually. So like you see this is a DIN rail. See this is a power supply will be attached to some railing will be there. And this is a power modules where we have one strap will be there where we'll fix it. This is an open frame, so completely open frame air cooled. And this is the enclosed one. So this is a desktop adapter is there, where this is a wall mounted adapter is there. So like this, industry you see the same, maybe these voltages are same, currents are there, but based on the application need, so it is modules are differently, it is designed actually. We have constraints like this, okay. And now we see the, example like morning also we showed you this, electric vehicle complete, okay, battery to wheels, how we connect through power electronic, DC to connector. So finally you see the product like this. So DC, fast charger, okay. So like this you see complete model, how the elements are completely packed and bring to the one single printed board, PCB. And finally we'll make this kind of enclosure actually. So this is how it will be delivered to the commercialization purpose. And this is one example where I am bringing here. So block diagram of the mobile power supply. So you have mobile, mobile power supply, okay, adapter. So how do you design the adapter? So first is any task, first what we should do, we should come up with a block diagram. What is a block diagram? Which will tell you the relation between input and output. So what is input? So 230 you get it, 230 AC, 50 Hz, and it will draw the current based on your load, okay. That can anyway it will deliver because it's small one. So what is the voltage required? 3.3. What is the milliampere? 0.5 milliampere something, okay. Now you see the connection between them. What is the energy conversion process required? So DC to AC, AC to DC, and then you have high frequency transformer, you the rectifier, and finally we do the filtering, and then but you want to get the exact output, then you need to have a closed loop operation. This is a very fundamental flow. So now we need to, in this block diagram, we need to fix it, each block diagram. So what is the component, what is the sizing? Selection, design and sizing is, complete, should be completed at this stage. Now you need to go with the schematic. Inside each block, now what is the schematic? So each, what is the each, component, if you selected 1 millihenry, why it is 1 millihenry, what is the design, what is the calculation? So like that, each block you should have. Now I selected this IC. So why this company IC? Why not other IC? Is it right? So like that, each component you need to fix it and complete the schematic. So block diagram, next is the schematic. So then you have input is there, you have output is here. Okay. Now that schematic, now you take it to simulation softwares. Okay. So open source software is also there now. So you put them all the components now, you make the simulation here. Okay, like that you make the simulation and see that whether you are getting the desired results and all. And next is, so once that simulation is successful, then that convert the schematic into finalize into PCB format. So there are some softwares also there where you can copyright. So you can make a company name, this is a copyright. So this design is made by this company, this is a copyright, this is a version 1 like this and all. So this way you need to freeze your design schematic diagram in the data, sheet, okay, schematic sheet. Now that will be sent to PCB design. So same thing. So if you, till that you can do that. Okay, PCB design, if you are not expertise, there are people are there in agencies in the market. So you just send the schematic diagrams sheets to them, and they will develop this actually, or you can develop if you know the PCB work. So they will develop completely. So you need to explain that, even so from here this point where it will go next. So this point is connected to this. So both are VCC. So like that. Okay. So every point should be connected and labeled properly. Then the PCB design will be completed. Okay. So once the PCB design completed, let's go with the printing. So in this 1 layer, 2 layer. So 2 layer means you have a printing components placed on the top, bottom also. You have optimized and the same, same sheet. So you will get a optimized and then placed components on that. Now that's how you print it. Finally, you have to procure. Okay, even if you don't have procure, so you need to give this bill of materials. Okay, complete each component specification, which company, which make, which is the rating, and like this, if you give the company, and then they will procure it. So along with the PCB printing, they will mold it all the components on the PCB. So finally, we can test it actually. So once the testing is successful, then we can go with some kind of certification. So we need to get, before commercialization, we need to get the testing as per standards is done or not. So once you get the testing, then make the enclosure and then commercialize it. So this is how the industries work it actually. And we did this kind of things. We did it. We trained students in internship programs and all actually. And finally, opportunity types actually. So opportunity, first one opportunity will come and knock your door. Is it right? So then ideally what we should do, we should open and then grab the opportunity. Okay. If you neglect it, sometimes students will ignore it. Okay. Students will ignore it. Okay. What is whatever reason? Maybe sometimes they get email to their job offers to email, but the students they never open the emails. They only see WhatsApp. Okay. Then they lose the opportunity. So like this. And then you need to search a long way and get the opportunity. Sometimes you need to struggle, you need to spend your time also. So that home. And next is plenty of opportunities around you always, but those are invisible, but you should identify and grab them. That's your responsibility. Sometimes we feel that some faculty, nobody working in our faculty, some AA or ML, but there is some faculty in our own college or department, somebody is working it. So that's how we need to see. If we're not invisible, you should make visible them. And sometimes call for opportunity, you need to come forward and apply. Even jobs, okay, any workshops, is it right? Any project proposals, you need to come forward and apply. And final one, so sometimes call for opportunity, first come, first serve based. So limited, okay, even cinema hall, so 200 capacity, cinema, so favorite hero. So I need to go first and then get the ticket. And food, okay, maybe marriage and all, they prepare food for limited people only. So like that, you will get some kind of first come, first service based only. You should not neglect them. So that means you should not wait for a, the last date or something like if you are anything applying or something. Okay. So that's it. Okay. And I'll show you some of the 1 or 2 portals actually. One thing you can search it like this, MathWorks BMS like this. You can see this is the first link is coming. So in this link, you can see from the starting onwards, how do you do these some exercises on the BMS and all. So you can see that here videos also there. You can see here how to develop battery management system. 4 videos also there in this. So like this. So at the end, if you come, these are all different projects. Okay, it's implemented. It's given here, and they give some coding also here. You can find coding also. I click this development this one. How to develop a battery management system in Simlink. This is a white paper also available. It's open source, free. Okay, and this is the first video. You can see BMS overview. Okay, simple simulation. Video is 5 minutes, 20 minutes, 5 minutes, 20 seconds. This is a BMS algorithm. This is SOC is estimation like this, and you can see the download. You can download the code also. Okay, they made it already. I mean, open source. So like that, you can have it, and even you can see some power electronics related also. There's one community is there, MathWorks actually. So MathWorks power electronics like that. This is a power electronics simulation. Okay, anyway. So then power electronic simulation, this one, you can go to electrification. Similarly, power electronic community also will be there. So you'll find some of the good simulation studies. So you can refer to students also like this. So this simple one. So this is a digital controller boost converter. Simple. So nicely they explained it like that. They are bringing a lot of good platforms like this and all. So this one. And sometimes you see some white papers also. So this is a white paper on developing BMS with MATLAB tuning and with HAL. So hardware in loop. So this is a white paper actually. So this is a schematic, block diagram way. So how to build a rapid prototype actually. So in this they mentioned this TA, DSP based C2000 series microcontroller actually. So it is given here. Same thing. You can see this is a cell device. So battery management simulating state of art charge with Coulomb. This is a Kalman filter method. So estimation of SOH. So this is simulating. Same thing it is given in web page. Same thing. Okay, this is a C2000 microcontroller. So like this. Okay. And other companies also they provide. If you go to other industries like TA and ST Microelectronics, they also provide a lot of manuals also. This is from Texas Instruments. This is from Texas Instruments. So this is also intelligent battery management system charging wire. So Texas Instruments like that. So they give some kind of schematic. Schematic is not clear there. So this is one. You can see this is a AC single phase rectifier, AC to DC. You have 400 volt DC is there. Okay. And from there now 400 DC. Now you need to connect to battery. So again here, so you will have a charge controller here. DC here. So they have used real time C2000 microcontroller. I think cost also very much less than 5,000 or something actually. So this one is there. So like that industries also they release like a reference designs. It's called a reference designs actually. So they implement something, they will make it open source. And you can try to implement the same thing. They don't have any issues and all. If at all, if anything is there, they will mention the last page. Notice for TA design information and resources, they give some copyright issues and all. So mostly if it are released open source, mostly there's no issues and all, we can utilize them directly. Okay. So these are the things actually. Okay. And I request to go to maybe that websites like a morning I showed you FAME India and then Niti Aayog website for updates on the EV electric vehicles. That I think that is the best source for to get the more knowledge on EV developments and challenges. Okay, so that's it. Okay. I hope I covered the relevant topic.